Thank you so much for attending this talk, Adaptive Socio-Technical Technical Systems with Architecture for Flow, and I'm very happy that you have found this room. It was kind of like a challenge from me. So little heads up at the beginning. I have the tendency to cover a lot of content in my talks, but I will provide a link to my slide deck at the end of the presentation. And also, I am writing a book about, I don't know how long I have already mentioned that, but I'm writing a book about this topic if you would like to explore more. It's in the signature series of Vaughan Vernon at Edison Wesley. So, when building systems in general, we are facing the challenges between building the right thing and building the thing right. And building the right thing addresses effectiveness, such as are we building a solution that is closely aligned to the business and user needs? Are we generating value for our customers? Have we understood the problem? Are we sharing the same common understanding? And building the thing right, on the other hand, focuses on efficiency, for example, efficiency of engineering practices. And that's not only crucial to generate value for our customers, but also being able to deliver that value to our customers. And how fast can we deliver the changes? And how fast and easy can we make changes effective and adapt to new circumstances? So the one does not go without the other, but as Dr. Russell Eckhoff pointed out, one of the pioneers of the system thinking movement, said, doing the wrong thing right is not nearly as good as doing the right thing wrong. Or say it a little bit shorter, crap delivered quickly is still crap. Unless, as John Cutler said, unless we learn something from that and act on that learning. So to build the right thing right, we need to build adaptive socio-technical systems that are optimized for fast flow of value and constant feedback. And one approach out of many that I would like to share with you today is combining Wardley Mapping, Domain-Driven Design, and Team Topologies, which are phrased as architecture for flow. And we can start with creating a Wardley map that is visualizing the landscape and organizations operating and competing in. And a Wardley map is part of Wardley Mapping, a business strategy framework invented by Simon Wardley, who is also going to give the keynote tomorrow, I guess the closing keynote, and also did a masterclass yesterday as well. So a Wardley map emphasizes to start with the users first, and starting from the user's perspective aligns very well with building the right thing. And Clayton Christensen, the inventor of the Jobs to be Done series, stated that people buy products and services to get a job done. So in order to help users to get their job done, we need to know who our users are in the first place and what jobs they want to accomplish. And we also need to identify their desired outcome to achieve, to accomplish, when they want to get a job done while executing a job. And the jobs to be done and the user needs, they are describing the problem space and are remaining the same regardless on how we are going to solve it in the solution space. So they don't care if we use Kubernetes, serverless, AI models, and so on, as long as we are fulfilling the user needs. So let's use an example of an online school solution for junior students, and the potential users could be the teachers, the junior students, the school principals, school administrators. And just to keep it simple, we focus on the teachers only. And the teachers, they have the core functional job to facilitate remote learning on this online school solution. And to accomplish this job, the teachers need to prepare learning material, they need to assess the student understanding with assignments, they need to track the students' progress over time, they need to facilitate communication with the students and also ensure and set up a secure access to the learning platform, for example, with sign-up and sign-in processes. And in the solution space, those user needs are directly or indirectly fulfilled by a chain of components that generate value for our users by satisfying those identified user needs. And that's where we can blend in the value chain, that is the y-axis of the Wardley map, where the users and the user needs are representing the anchor of our map. And deriving this value chain helps us or ensure us to that we are addressing the right problem and create value that aligns well with the user needs we have identified. And the value chain itself shows how different components connect in order to generate value and visualize also their dependencies. And we can start simple with just only identifying some components and iterate later on. So in the example of the online school solution, the teachers are directly interacting with an online school component. It's most visible to the teacher and it's located at the top of the value chain. And this online school component, we later will decompose it when we come to domain-driven design, but this online school component depends on other components such as foundational infrastructure components, and which are less visible to the teachers and are residing lower at the bottom of the value chain. And those components of the value chain are then typically mapped to evolution stages, such as on the x-axis, such as Genesis with brand new things, then custom build, product and rental, such as off-the-shelf products, open source software solutions, and commodity and utility at the right. And each evolution stage come with different characteristics. So towards the left spectrum, towards Genesis, the components are changing far more frequently than components on the right spectrum towards commodity and utility. So on the left, we're dealing with high level of uncertainties, unknown unknowns, and an undefined, poorly understood market, while the components towards the right spectrum, towards commodity and utility, the components become more stable, known, widespread, standardized, and the markets are well-defined and mature. And a Wardley map itself is supposed to be, not supposed to be perfect, but provides a very useful approximation or quite useful abstraction. And a great value comes from creating this Wardley map together within a group in order to generate or create a common shared understanding of our landscape, and also helps to challenge our own assumption within that group, and also helps to identify areas where to invest, where to innovate, what to evolve or outsource in order to gain a competitive advantage. And we can also use, or I personally use this Wardley map as a high-level entry point, a high-level discussion entry point to assess our current flow of changes. So to build the right thing right, we need to optimize our system for a fast flow of change and constant feedback. And for that purpose, we can go along the dependencies in our value chain and analyze how a change would flow through our system. For example, when introducing functional changes, we can analyze what components might be affected following the dependencies in our value chain. And also, what teams do own these components that are involved in this specific change, and how do these teams depend on each other and need to communicate and coordinate to make the change effective in the end. So by assessing how a change would flow through our system, we can also reveal potential blockers to flow by analyzing what is preventing flow along the value chain. And this can also be complemented with value stream mapping that allows to identify constraints in our value stream, as James Lewis is giving a talk tomorrow about how flow works. I guess that's the title of his talk. And we can also use the value chain or value stream mapping as well. So there are complementing techniques and methods to identify constraints and identify blockers to flow. And analyzing blockers to flow along the value chain can be done from various perspectives. For example, from an architecture point of view, we need to analyze how parts in our system are coupled together. So in our example, the online school component itself has evolved over time. Maybe that sounds familiar, but it has evolved over the time into a monolithic big ball of mud with a messy model and no clear modularity boundaries. But a big ball of mud that leads to tight change coupling, and tight change coupling itself then impedes our flow of changes, and as changes in one part of the system can have unpredictable side effects on other parts of the system, and then leading or increasing the risk of defects, breaking things, and also the risk of to do rework again. And the big ball of mud also affects the team ownership. That's where we come to the next perspective that we can analyze. So a messy architecture with blurry and fuzzy boundaries, they make it really difficult to establish clear ownership boundaries. And that leads to a lack of ownership, of clear ownership, which decreases on the one side accountability, and also which potentially leads to, oh, not my job syndrome. But that can then also cause decision delays and also impeding our flow of changes. And with a business logic that is mingled together in a messy model with no clear modularity boundaries, that will also could increase the mental effort to understand a piece of code, and also including understanding all the dependencies in a largely intertwined system. And that could also, in another effect, also lead to teams that own too many or too large parts of the system, and which then can potentially then also increase their team's cognitive load. And if the team's cognitive load is largely exceeded, that can introduce also delivery bottlenecks. And we also need to analyze where teams depend on each other. For example, other teams' activities or tasks to get their work done. So, for example, do the teams have to repeatedly hand over work to other teams at a later stage of flow in order to get their own work completed? And for example, the teams of our online school example, they are currently organized as functional silo teams. So when introducing a functional change or a change from front end to back end, that requires repeated handover from the front end to the back end to the infrastructure teams. But handover requires a high amount of communication and coordination efforts between multiple teams, and also introduce wait times. So you're waiting until the other teams is ready with their changes. So that it introduces communication and coordination efforts and wait times. So that is then affecting our flow of change as well. And if teams are missing specific capabilities or specific skills, and need to bring in people with this specific missing expertise into the teams so that they do something in order to get our work completed, that is also could impede our flow of changes, particularly when the people that we depend on with their expertise are not available when we need those. And if teams depend on external decisions, for example, from management or waiting for approvals, that is also, then we can't progress with to complete our work. So every dependencies with other teams to other teams require some level of communication and coordination efforts, and that increases the probability of waiting time and delays, and particularly when the people that we depend on are not available, or the teams that we depend on cannot keep up with the demands placed on them, so the other teams we depend on are becoming constrained, and then also decreasing the system's overall performance. So if teams have to interact with many other teams to get their own work completed, that is potentially slowing down the flow of value. And another aspect of building this thing right is assessing efficiency gaps. And so if the evolution stages of the components we use internally in our organization differ from the equivalent ones that are available in the market, that might indicate an efficiency gap. So, for example, are we custom building components that do not belong to our core domain? That is very important, where equivalent products or services are available in the market, as available as product, for example, or as a utility, or are we using components in our organization as off-the-shelf products where equivalent ones are available as commodity? For example, one typical situation is, do we have our own data center with on-premise infrastructure versus using cloud-hosted services? So that can then indicate an efficiency gap. And so that means that then we are potentially lagging behind in terms of efficiency, especially when we compare the value chain or the Wardley map of our competitors with ours, and they are establishing a value chain on top of further evolved components. So after we have identified the blockers to flow, so let's unlock them also by bringing those together again, combining Wardley Mapping, Domain-Driven Design, and Team Topologies as architecture for flow. And we can start again with a Wardley map. And the Wardley map I usually use then as a visual tool that steers us through the optimization. And to optimize for fast flow of value, we need to first identify what drives value or what drives changes in our organization. And that requires to identify where the most important changes in our system occur, the streams of changes. And the user needs of our Wardley map, they are good candidates of customer-driven streams of changes. So we need to structure our teams or our system around these customer-driven streams of changes where it matters most. And the user needs are not only representing the anchor of our Wardley map, but also represent the problem domain. And that's where we can bring in domain-driven design. So who has read the Blue Bible of Domain-Driven Design from Eric Evans? A few hands up. Keep it up. Who of you have read it until to the end? So I usually personally have to put it down because it took me 4 times, to be honest. But it's really dense and it's really a lot of great information. But it takes the time to digest it. So domain-driven design helps us to gain a shared understanding of our problem domain, but also helps us to partition our problem domain into smaller parts, into the subdomains. But not all subdomains are equal. Some are more valuable to our business than others. We have different types of subdomains. So the core domain, that is the essential part of our problem domain that is providing competitive advantage. So that is the one that differentiates us from our competitors. And that is the one that we have to strategically invest in most. That's the one that we should build in-house. The supporting subdomain helped, as the name indicates, support the core domain or complement the core domain's offering. They do not provide competitive advantage, but are necessary for the organization to succeed and are typically prevalent, typically existing in other competitor solutions as well. So the supporting subdomains are specialized, but not differentiating. And so if highly customizable products are available, then it's, we can use buy or use off-the-shelf products, open source software solutions if they are highly customizable. And if the supporting subdomains require a very high level of specialization, then we should custom build those supporting subdomains, but being aware not that our strategic investment should go in our core domains. So generic subdomains are subdomains that many business systems have, not only our competitor solutions, but every other system, for example, authentication or registration. So they aren't core, they provide no competitive advantage, but businesses cannot work without them. So generic subdomains are neither specialized nor differentiating, but using off-the-shelf products or buying or using off-the-shelf products, open source software solution, or outsourcing to utility suppliers, that should be applied to generic subdomains. And the subdomain tabs in general helps us to focus our strategic investment and support our build, buy, and outsource decisions. So we have discovered our subdomain types and get an understanding where to focus our major development investments. But so from a problem space point of view, but when we're switching now to the solution space, the solution of our subdomains are currently all mingled together in a monolithic big ball of mud with a messy model and no clear modularity boundaries, which is causing, as we have identified earlier, tight change coupling, lack of clear ownership, high team cognitive load, and also an inefficient focus of development effort on non-differentiating parts that are blocking our fast flow of change and also in introducing inefficiencies. And to mitigate those blockers to flow and decreasing our inefficiencies, one aspect is to consider to leverage modularity with high functional cohesion and loose coupling by designing a modular, well-encapsulated, loosely coupled system. And that's where, that requires to decompose our online school solution into modular components, and that brings us to the bounded context of domain-driven design. And the bounded context itself groups related business behavior together and defines where a single domain model can be applied. And the single domain model then encapsulates particular business logic that is applicable for a specific subdomain. And bounded contexts are also enforcing high cohesion and modularity from a business behavior point of view, and also indicating good domain logic specific themes to split our systems into smaller, modular, well-encapsulated parts, and also serve very well as ownership boundaries. So, and we're coming back to this when we address the team perspective. So designing bounded contexts and domain models, that typically involves a close collaboration between the domain experts and the development teams in order to gain a shared understanding of the domain. So we have to understand our problem domain first before we can provide a solution. And there are different techniques available that are complementary with each other, like, for example, event storming, domain storytelling, example mapping, user story mapping, and more. So at this stage, we have discovered subdomain types and modular bounded contexts so that we can better target our strategic investment. And now we can focus our major development efforts around our core domain-related bounded contexts that provides competitive advantage by building them in-house and also increase our expertise in that area. And for the non-differentiating bounded context, we need to evaluate whether we can leverage existing solutions. For example, for the generic subdomain-related bounded context of identity and access that does not provide competitive advantage and entails some common standardized functionality that require little to no variation. And here we can leverage existing solutions like off-the-shelf products, open source software solutions, or utility services that are available in the market. And for the supporting subdomain-related bounded context, the decision whether to build or buy is a little bit more nuanced than for the generic subdomains. So they are not core, but specialized. And they are playing a significant role in supporting the core domain-related bounded context. In our example, for example, we have evaluated existing solutions, but we concluded that a high level of specialization is required, which cannot be provided by existing products. In that case, we then decided to build a custom solution, which is justified for supporting subdomains, but being aware that it's not differentiating our solution from our competitors. The next aspect to consider is whether we can leverage further evolved components than we currently use in our organization, and in order to increase our efficiency. So in our example, we could then decide to migrate our on-premise infrastructure components to cloud-hosted services that are available as commodity in order to close our previously identified efficiency gap. So far we have unlocked blockers to flow that are related to software architecture and our efficiency gaps. But considering the socio-technical part of our system, we also need to bring in the team perspective, and in order to unlock our blockers to flow in regards to team ownership and team dependencies, and also the interaction between the teams. So that is where Team Topologies can help us with. So who of you have read the book Team Topologies? 25.27%, I would say. So just give you a brief introduction about the team types. So Team Topologies provides very well-defined team types and interaction modes. And so the autonomous cross-functional streamlined teams, they are aligned to a continuous stream of work and focusing on a fast flow of changes. But to be able to produce a steady flow of feature deliveries, in order to be able to focus on a fast flow of changes, they need the support from other teams, for example, from the platform teams. And the platform teams, they support the streamlined teams delivering their work, and also are responsible for platforms that the streamlined teams can easily consume, so that there is no handover involved. So, and the platform can vary in its level of abstraction. For example, at a lower level, a platform can abstract away infrastructure and cross-cutting capabilities, and at a higher level, a platform can also reflect a design system or a data platform and more. So the platform teams, they provide internal self-service services and tools for using that platform that they are responsible for, and also make the streamlined teams self-sufficient. Or the streamlined teams can also get support from the enabling teams. They work as internal coaches and mentors and also help to identify missing capabilities and also upskill then the other teams. Or they can get support from the complicated subsystem teams. This is an optional team type, and they are supporting the streamlined teams on particularly complicated subsystems that require very specialized knowledge, where it's kind of like PhD level knowledge that needs to be involved. So, and all of them aim for increasing the autonomy and also reducing the team cognitive load of the streamlined teams to enable a fast flow of change in the end. But arranging teams in these team types is not enough to become effective and efficient. It's also how they interact with each other and when to change the interaction and evolve the interaction along a journey is also relevant in order for organizational effectiveness and efficiency. So in there, Team Topologies has provided 3 different team interaction modes. With collaboration, teams are working very closely together and which is very important, over a limited period of time. And it's suitable for example, rapid discovery, for innovation, for example, when exploring new technologies, LLMs, for example. And but collaboration is meant to be short-lived. And X is a service that is when one team needs to use, for example, a code library or component, an API or platform that can be effectively provided as a service by another team and works best where predictable delivery is needed. And facilitation, that is the interaction mode that comes into play when one team needs active help from another team. And that is the interaction mode that's very typical for the enabling teams. So let's go back to our Wardley map. And the next step could then, from the team perspective, to identify or to find suitable team boundaries that are aligned to a customer-driven or customer-facing streams of changes. And as I mentioned earlier, the bounded contexts we have designed before, they also serve as very well-defined ownership boundaries. And that makes then the bounded context, besides being good domain-specific schemes to split a system apart, also good candidates for team boundaries for streamlined teams. And so another aspect that we need to consider is, in order to mitigate the previous identified blockers to flow, is that we need to optimize the team's cognitive load. As I mentioned earlier, if it's largely exceeded, it also becomes a delivery bottleneck. And to optimize the team's cognitive load, we have to limit the number, the size, the complexity of the software system that a single team has to work with or is responsible for. And this can also bring us as heuristics back to the evolution stages and the characteristics of our Wardley map. So as I mentioned in the beginning, according to the characteristics of the evolution stages, the further left a bounded context or component in general is located, the higher the level of uncertainty is, which then requires practices that are more focusing on discovery and exploration. And components in Genesis on the left side, they tend to change far more frequently than components in commodity and utility. And for components in commodity and utility, we can draw on best practices, providing a clear path to action. And each evolution stage addresses different practices, like related to their path to action, from best to good, emerging, and novel practices. So as a heuristic, the more unclear the path to action is, the higher the level of cognitive load is. That means that a single team could take ownership of more or larger bounded context or components that are residing in commodity and utility on the right than on the left. And another thing is to optimize team cognitive load is to establish clear responsibility boundaries so that we don't have overlapping responsibilities. So that means, for example, for each bounded context, a single team only should take responsibility for. So not sharing bounded contexts across several teams, so that would diffuse the ownership. However, one team can own several bounded contexts. On the other side, that's possible. Coming back to what I said when I introduced team topologies, in order to be able to focus on a fast flow of change, the streamlined teams are relying on other teams supporting them delivering their own work. For example, from getting support from platform teams that provide platforms that the streamlined teams can easily consume in order to reduce then their cognitive load. And this brings us to to the requirement that we need to identify services that can support a reliable flow of changes and can be easily consumed as a platform, providing self-service capabilities, reducing then the team cognitive load of the consumers. In our example, the infrastructure-related components of our Wardley map located in the commodity and utility evolution stage, they could be potential candidates that are suitable for forming a platform that can be effectively provided as a service by a platform team. And so besides reducing the team cognitive load, providing self-service capabilities that aims to make the cross-functional streamlined teams then self-sufficient, so they don't have to pull in another team for expertise. And eliminates also the blocking dependencies of handover and decreases then also the corresponding high communication and coordination efforts, including wait times that I introduced earlier. And when talking about team dependencies and ownership, we can also switch from the external product view, where we have the teachers as the external users with their user needs, now to the internal platform view, where we then regard the platform as a product, and where the teams are now becoming our users. So we are now switching from one Wardley map to another, where now the streamlined teams become the users of our services of the services that the platform team provide. And the streamlined teams, they also have different user needs like provisioning, managing infrastructure, building, testing, releasing, deploying, operating, monitoring, the service or bounded context they're responsible for. And to fulfill these user needs, the streamlined teams, the platform teams can provide a variety of platforms that the streamlined teams can easily consume. For example, providing an infrastructure platform that enables the streamlined teams to provision, manage the infrastructure on demand, for their services they are responsible for. So in general, the platform can start very small. Team Topologies calls it the thinnest viable platform, and can start very small. It doesn't have to be a fully fledged digital platform from the very first beginning, because then you never release it and never then also incorporate your feedback from your users. Instead, it can start with simple documentation at the beginning, or with standards, with best practices, templates, and can evolve later into a digital platform with self-service APIs and tools. And also, the build and release platform then supports the streamlined teams to build, test, and deploy and release their services in bounded contexts. And also, as I said, a platform can vary in its level of abstraction. At a higher level, also can also reflect a design system to, for example, to achieve a consistent, well-defined visual language at scale. So the platform team owning this design system then can provide style guides, standardized design principles, widget libraries, and more. Or in order to operate and monitor the services, the streamlined teams require like dashboards, alert mechanisms, incident management, observability capabilities, and have to adjust it according to Charity's Mayor's talk this morning, of course. So these capabilities can be provided by the platform team as operation and monitoring platform, and these platform teams can also provide a variety of easily consumable platforms that satisfy the user needs of the streamlined teams to make them self-sufficient and help them supporting them delivering their work by reducing handover and minimizing the team's cognitive load. And also, another aspect to consider for optimizing for flow is to identify and close capability gaps. That's where the enabling teams can come in. And cross-functional streamlined teams, they need to cover a wide range of capabilities and skills, such as software design, architecture, application security, and very much more. So that is a lot to cover, and where the specialists of enabling team can be pulled in on demand and upskill the streamlined teams to make them self-sufficient in the end. Or this enabling team can also support the platform teams by coaching them about how to improve developer experience, or how to design a scalable, reliable, and secure platform, and much more. And plus, also the enabling team can coach them about skills related to product management, effective communication, good documentation, improvement of practices, and much more. So the enabling teams, they facilitate as internal coaches and mentors and help to upskill the other teams so that they then become self-sufficient, which also unlocks then the dependency on people with a particular expertise to do something before they can complete their work. So they are then self-sufficient to continue their flow of changes. But it's not only relevant, the skill set itself is not only relevant, but also the preferences and mindsets of the team members. So when composing teams, Simon Wardley, he suggests to think aptitude, like skill sets, and attitude, like mindsets and preferences, which means that not only the skill set is relevant for team members, but also their mindset. And so, for example, dealing with components in different evolution stages also requires different mindsets. So Simon Wardley, he introduced then like explorer, villager, and town planners, mindsets and attitude, which was known before as pioneer settlers and town planners. And my personal take here is that there should exist a mix of mindset in each team, and depending on the evolution stages, a particular mindset is more prevalent. So, for example, teams owning components in Genesis and custom build, they might tend towards an explorer mindset, which preference for discovery and experimenting. They are also very fine with failure. Teams owning components in product and rental might prefer to improve and stabilize with a villager mindset. And teams owning components in commodity and utility, they might prefer to mature and optimize with a town planner mindset. And this mix of mindset with a tendency towards a specific mindset, that enables the teams to respond in different ways to different situations. So, for example, also a team owning commodity components can also switch to exploration modes when using agile techniques, and when, for example, exploring new technologies, which is new technology that they have not explored before. So this architecture for flow approach that I described a little helped us to unlock a variety blockers to flow from the architecture, the team ownership, and the team dependency and efficiency gap perspective. Now the question is how to put it in practice and how to then transition into the target architecture for flow. And there's something that, so we can transition with a team-first approach as a reverse Conway maneuver. So Conway's law states that the organization design system that mirrors our own communication structure. So in the converse, the reverse Conway maneuver then suggests to restructure the organization to then achieve the desired architecture. So we are going to apply this in the, I have to hurry. They apply to the reverse Conway maneuvers through incrementally, dynamically reteaming in small steps and evolving the interaction modes along the transition. For example, dynamically reteaming the functional silo teams into platform and streamline teams, where then the platform teams and evolving then the interaction modes along a cloud migration journey, starting with the platform teams, exploring cloud options that are available, so they are more on discovery and experimentation, and then, replatforming the underlying infrastructure components to cloud-hosted services. The first streamline team can form, and they can take care of refactoring the applications architecture, and we are splitting then the existing architecture into smaller parts. And this refactoring journey is supported by an evolution of interaction between the platform team and streamline teams, where, for example, the streamline team closely collaborate with the platform teams at the beginning to discover potential cloud options. This can then go into limited collaboration and then access a service. Next streamline team can form a refactor their bounded context area responsible for also getting now coaching as another facilitation interaction mode from the previously formed teams, and support them along their cloud migration journey. And the next teams can form, so that we then were able to resolve our blockers to flow from applying then the reverse Conway maneuver with dynamic reteaming and an evolution of Team Topologies interaction modes along a cloud migration journey. So coming to the end, the combination of Wardley Mapping, Domain-Driven Design, and Team Topologies helps us to generate a sustainable value aligned to user needs. It helps us to unlock blockers to flow and focusing our development investment on our differentiators that provides competitive advantage, and also helps us to close potential efficiency gaps depending on our context. It helps us to align our teams and evolving their interaction to the system we build and the strategy we plan. So the combination of these three methods, they provide a very powerful tool set to design, build, and evolve adaptive socio-technical systems that are optimized for fast flow of change and constant feedback, and that it can thrive in the face of rapid changes and help us to build the right thing right in the end. And it does not stop there. It's also investing in building adaptive socio-technical systems helps us also not only equips us to respond to changes introduced by others, but also helps us to lead future changes introduced by us. So where we are then now in a position to impact the landscape to our benefit, where we create alliances with others to increase our ecosystem, where we are first mover to commoditize component that others can innovate on, and for future components, derive future components for industrialization. And so then we are in the driving seat of change. And with that, here's some resources that you can also use for diving deeper into that topics. I'm sorry, it was a lot of content. As I said, there's a book still in the pipeline. And with that, thank you so much.